This is the review video for the IB Math Studies Final Exam Spring 2018 review. Question number 1 is from topic 3. We're talking about probability. So they give us a tree diagram and give us some information. They tell us that the probability that Nikita will play a tennis match on a grass court is 0.4, which means the probability that she plays on a not grass court is 0.6. These always have to add up to 1, either grass or not grass. And then the probability that she wins on a grass court is 0.35. So the probability that she loses on a grass court is 0.65. Again, these have to add up to 1. Every branch of the tree adds up to 1. So then over here, the probability that she wins on not a grass court is 0.25, and that means that the probability that she loses on a grass court, not a grass court, is 0.75. Part B wants us to know what's the probability that she wins a match. So there's two ways this could happen. She could play on a grass court and then win, or she could play on not a grass court and then win. So because there's an or, we're going to add these together. And then we have a compound probability here. So the probability that she plays on a grass court times the probability that she wins on a grass court. And then we're going to add that to the probability she plays not on a grass court times the probability that she wins on not a grass court. So here the 0.4 times 0.35 is the probability that she wins on a grass court. Here the 0.6 times the 0.25 is the probability that she wins on not a grass court. So the total probability that she wins is 0.29 or 29%. Question number 2 is from topic 5, it's trigonometry. So they give us two boats with some triangular shaped sails. Both triangles are right triangles. And then they give us some lengths and angles. So part A wants us to find side AC. So they give us an angle and they give us a side. And we're looking for the hypotenuse because it's the one directly across from the right angle. We're given the side opposite of the angle, so we want opposite over hypotenuse, which is sine. So we get the sine of 76 degrees is 5.45 over AC, the side that we're looking for. So if you cross multiply, you end up with AC is equal to 5.45 over the sine of 76 degrees. Plug this in your calculator, you end up with 5.62 meters. Part B wants us to find the side RT for Williams sail, and they give us that the area is 10.7 meters squared. So area is 1/2 base times height for a right triangle, and so 10.7 is equal to 1/2, 2.8 is the base times the height RT that we're trying to find. So then if you multiply this out, you end up and divide across, you end up with RT to be 7.64 meters. And then part C wants us to find the angle RST, so this angle over here. Well, we just found the opposite side, and we know the adjacent side, opposite over adjacent, is tangent. So the tangent of this angle is 7.64 that you found in part B over 2.8. And then we want to find the angle, so we need to take inverse trig. So S is the tangent inverse of that ratio, so the angle is 69.9 degrees. Number 3 is a topic 2 question. So they give us a cumulative frequency graph for students' mathematics scores. And first question is we want to find the median. So we know there's 160 students. The median occurs halfway through, or in this case at the 80th student. So I'm going to draw a line from the 80th student to our curve and go down, and we get that it's about 48 points. They tell us the lower quartile is 40, and they want us to find the IQR, or the interquartile range. So in order to do that, we need to find the upper quartile, which happens 75% of the way through your data, or after 120 students. So I did the same thing, drew a line across, and went down and found that Q3 is about 58. So your IQR, which is on your formula booklet, is Q3 minus Q1, or 18. So we're going to use this data on our next slide to create a box and whisker plot. So then we want to use the data from the previous slide to create a box and whisker chart. So they tell us that the minimum is 6. We know that the Q1 is 40. We found the median to be 48. We found the Q3 to be 58, and the highest score they tell us is 90. So all of those get lines, and then you get your box in the middle between the Q1 and the Q3 with the line at the median, and then your whiskers go out to the min and out to the max. Make sure you use a straight edge on this. You will lose points if it's obvious that you didn't use a straight edge. So number 4 is a topic 5 question, some three-dimensional geometry. So the first question, part A, wants us to find the volume of each of these tuna cans. The fresh wave can is a rectangular prism, so the volume, which is on your formula booklet, is the length times the width times the height, and they give us all three of those dimensions, so multiply all that together, you get 140 centimeters cubed. The happy fin tuna is a cylinder, and the volume again is on your formula booklet, pi r squared times the height. They give us the diameter, so you have to find that the radius is 3.5. Multiply all this together and you end up with this, or 154 centimeters cubed, to three significant figures. Part B tells us that a can of fresh wave costs 90 cents, and it's the same price per centimeters cubed for each brand. So then we know that the price per centimeters cubed is 90 cents per 140 centimeters cubed, and the Happy Fin tuna has 154 centimeters cubed in its volume. So if we multiply these together, you end up with 99 cents. Since they gave it to us in cents, we need to answer in cents. So it should be 99 cents, not $0.99. Number 5 is from topic 3. We have some logic. So they give us three statements, Z, Q, and R. And part A, they want us to write down not Q. Remember, this little symbol here means not. So this is, if Q is that X is irrational, then not Q would be that X is not a rational number or is an irrational number. Part 2 says write down a value for X that makes that statement true. So anything that's not rational, pi, e, square root of 2, square root of 3, square root of anything that is not a perfect square would fulfill your answer to part 2. Part B wants us to write down if X is a real number and X is not a rational number, then X is not an integer in symbolic form. So this first part, if then, that's going to be your single arrow. X is a real number, that's your statement R. Not a rational number is your not Q, and is your little caret. And X not an integer would be not Z. So you have parentheses R and not Q implies not Z. And then you want to justify why you don't actually need a truth table for that. So you could say something like all integers are rational, so if it's not rational then it can't be an integer, something along those lines. Number 6 is from topic number 1, and it is a sequence problem. So they give us some information about an amphitheater for an Olympic Games, and we want to find the common difference, or how many seats are being added in each row. So using the formula booklet, we have that our arithmetic sequence, because you're adding every time, is u sub n is equal to u sub 1 plus our common difference, n minus 1. So they tell us that in the 6th row there's 270 seats. So I plugged in 270 for u sub 6 and n to be 6. And they tell us that the first row has 240 seats. And then I use this to solve that our common difference is equal to 6. They then tell us that there are 20 rows in the amphitheater and we want to find the total. So you could use summation on your graphing calculator, or you could use the formula that they give us in the formula booklet, that the sum of the first n terms is n divided by 2 times the first term plus d times n minus 1. So I plugged in all the information with n to be 20, u sub 1 to be 240, and d to be 6, and you get that there are 5,940 seats in the entire amphitheater. And then calculate percentage error based off of her guess of 6,500 seats. So again, that is in your formula booklet. Plug in 6,500 for your estimated and 5,940 for your exact, and then make sure you multiply by 100. You end up with 9.43% error. Number 7 is some more topic number 5. It's the geometry of lines. So they give us an equation, y equals 2.5x plus k, and a point that lies on that line. So if it lies on that line, that means it makes the equation true. So for part A, I can plug in 3 to be x and negative 2 to be y and solve for k that way, and you get k to be negative 9.5. Perpendicular lines have opposite reciprocal slopes. So if the original line has a slope of 2.5, then its perpendicular line has a slope of negative 1 over 2.5, which is negative 0.4 or negative 2/5. Write an equation in the form y equals mx plus c. We know that it goes through the point 3, negative 2. So I plugged in our slope that we just found, and I plugged in our point of 3, negative 2 into our point slope form and simplified down to this. You could also have decimals here, so y equals negative 0.4x minus 0.8. And then part D wants us to change this into standard form. So I multiplied everything by 5 to clear out our denominator. You get 5y is equal to negative 2x minus 4. And then I move everything over to the same side of the equation. You get 2x plus 5y plus 4 equals 0. Or negative 2x minus 5y minus 4 is equal to 0. Number 8 is some topic 4 questions. So it's talking about normal curves. So they give us this normal curve for life of a light bulb, and they want us to find the mean. So the mean is right in the middle, that highest point. So the mean is 5,800 hours. And then they tell us the standard deviation is 850, and they want us to find the probability that the light goes from 5,000 or is between 5,000 and 6,000 for a randomly chosen light bulb. So using your graphing calculator, if you don't remember, make sure you watch the video. You're going to use the normal CDF, and you get that the probability is 0.420. And then they tell us that it states 90% of the light bulbs have a lifetime of at least K. Make sure you draw your normal curves. You do get a point for that. So at least K means that it's going to be greater than. So you shade greater than, and since it's almost 100%, it's going to be pretty far over here on the right that you're going to shade. So I set up my little equation. Your calculator will not do greater than, so you have to change it into a less than. If its probability of being greater than is 0.9, then the probability of being less than that is 0.1. And then you use your inverse normal on your calculator, and they want us to give our answer to the nearest 100. So 4,700 hours is 90% of the light bulbs. Number 9 is topic number 1 for money exchange. So we're talking about exchanging 3,100 Chinese yuan into Brazilian real, and there's no commission charge. So part A, we want to know how much Brazilian real he ends up with. So we do our unit exchange here. So 3,100 Chinese yuan times 0.3871 Brazilian real per 1 Chinese yuan. Do this calculation. They want the answers to the nearest whole number, so you end up with 1,200 Brazilian real. Part B1 wants to calculate how much he would receive if no commission was charged. So 5% was taken away, so which means he has 95% of what he started with. So if you divide what he has now divided by the 95% or 0.95, he would have ended up with 300 Chinese yuan instead of 285. We want to know how much he started with, how many Brazilian real he started with. So that means he had X Brazilian real and he converted it into Chinese yuan and ended up with 300. So if you multiply both sides by the 0.3756, you end up with 113 Brazilian real. Number 10 is topic number 4, chi-squared. So you have 1,200 travelers, and they were asked how old they are and where they want to go. So part A wants the null hypothesis. So null is always independent, so age is independent of travel preference. Part B wants to find the degrees of freedom. So that is the rows minus 1 times the number of columns minus 1. So there is going to be 4 rows and 5 columns, or flipped, they don't really tell us, but 4 and 5. So then you end up with 4 minus 1 is 3, times 5 minus 1 is 4. You end up with a degree of freedom of 12. Part C wants to know what the chi-squared statistic would have to be to reject the null hypothesis. So the chi-squared statistic is bigger than the critical value to reject the null hypothesis. So any chi-squared statistic that is bigger than this 21.026, we would reject the null hypothesis. And then part D says if there are 1,200 total travelers and 285 of them were 61 years or older and 420 preferred Tokyo, we want to know what the expected value of 61-year-old and olders who wanted to go to Tokyo was. So to find your expected value, it is the row total times the column total divided by the total. So in this case, they just give us the totals. They're not actually set up in a table, but you do the same thing, and you end up with 99.8. Number 11 is topic 7. We have some calculus here. So they give us a function, f of x equals ax squared plus c, where c and a are just constant values, and they want us to find f prime of x. So you take our derivative. This is on the formula booklet. You treat a and c just like they're numbers. So bring the power down in front. 2 times a is just 2a. Reduce the power by 1, you get x. The derivative of a constant is just 0. So you get f prime of x is 2ax. And then they give us some information about the equation of the tangent line, or the point and the slope of the tangent line. And they want us to find a, and then in part C, they want us to find c. So if the equation of the tangent line at x equals negative 2 has a slope of negative 6. That means that if you plug in negative 2 for x, your slope, or your derivative, is going to equal negative 6. So if you do that, you find a to be 6 over 4 or 3 over 2. And then they also tell us the y-coordinate, so that's the original function. So if you plug in negative 2 into the original function, and I plugged in 3/2 for a also, and I set it equal to our y, which was 5, you get c to be negative 1. Number 12 is topic number 1. We're talking about some compounded interest and some money again. So this is the compounded interest formula, which is on your formula booklet. And part A wants to know how much interest he's earned after 2 years. So your interest is your future value, what you end up with, minus the present value, what you put in. That is how much interest you earn. So if you fill in all the information, your present value is 800, your ratio is 15, your K value, how much is compounded per year, is 12, because it's compounded monthly, over 2 years, and then I subtracted off the 8,000 we started with. So you end up with a interest of $2,778.81, because they want everything to 2 decimal places. And then part B, they give us some more information, and they want to know how much money she deposited into the account. So they give us the future value of 1,000, and they give us a rate of 17, and a compounded yearly means that K is 1, and K is 1 again, and it's 3 years, so N is 3. So you can either solve for your present value algebraically, or you can use the financial apps on your graphing calculator. Either way, you find the present value to be $6,243.71. Number 13 is topic number 1. So they give us this value r, which is the golden ratio, 1 plus the square root of 5 over 2. And they want us to find that to 5 significant figures. So first I just plugged it in my calculator to find the calculated value. And then 5 significant figures would be 1.6180. And then 2 decimal places would be 1.62. So now we have this rectangular window with sides x and y and an area of 1. And they want us to write an equation for that. So area of a rectangle, which is on your formula booklet, is area is equal to base times height, or side times side. So you get 1 is equal to x times y. And then they tell us that they want the ratio of these sides to be equal to the golden ratio r. So that means y over x, they want that to equal r. So using that, you now have 2 equations with 2 unknowns. You can use that with either algebra or your graphing calculator and solve for x to be 0.786. So number 14 is topic number 1 if you think of it as a geometric sequence, and it's also topic number 6, which is modeling. So they give us this equation to represent the number of rabbits on an island. And for part A, they want us to find the value of B. So they tell us that at time 1, because t is in weeks, that the value is equal to 210. So if you plug in 1 for t and set it equal to 210, you get B to be 1.05. And then they want us to calculate how many rabbits would be on the island after 10 weeks. So plugging in 1.05 for B and plugging in 10 for T, you end up with 325 rabbits, because that 326th isn't there yet, and you can't have a decimal amount of rabbits. And then they want to know that what time or how many weeks it would take to get this to this 1,000 rabbits. So if you set the n equal to 1,000, you use your graphing calculator, do you find that it would take 33 weeks to end up with 1,000 rabbits. Number 15 is topic number 7, so more calculus. And part A wants us to find dA dr, which is the derivative with respect to the radius. So they give us this equation for the area in terms of the radius. I rewrote 680 over r as 680 r to the negative 1 power. And then take the derivative. Pi you can just treat as a constant. You can just treat it as a number like it is. So you bring your power down in front. 2 times 2 is 4 times pi. Reduce your power by 1, you get r. Bring your power down in front. Negative 1 times 680 is negative 680. R to the reduce your power by 1, you get r to the negative 2. And then part B wants us to find the r value that minimizes the surface area. So minimize, that happens when your derivative is equal to 0. So set your derivative equal to 0, and then solve either using your graphing calculator or algebra, and you end up with r to be 3.78 centimeters.